Hello students, welcome to the physics session. In today's session, we will be discussing about heating effects of current and Joule's law. Okay, uh, especially the concepts of electrical energy, electrical power, and some questions related to combination of bulbs, like how to find the power consumed by a bulb and how to find when you connect two bulbs in series or parallel which bulb glows brighter, like kind of questions. When electrical devices are connected, how much power they are consuming, uh, which bulb will fuse, what is the meaning of fusing of the bulb. These points we'll discuss today. If possible, we'll try to discuss briefly about combination of cells as well. Okay, let's meet at 8:30, guys. Till then, take care. Bye bye.
Where is the duster? Is the duster? Where is the duster, man? Check it out. Okay. So we are doing current electricity, right? Current electricity. In this chapter, we are discussing about combination of resistance, right? I have discussed about combination of resistance and some numericals also I have discussed, right? Now let us see one or two questions based on this combination of resistors. Then we will discuss about electrical energy and power, electrical power. Okay. So first we will see one or two questions based on this combination of resistors. Some important methods. There are so many important methods are there. We have discussed already a few questions. So one of those important methods of questions is how to find the effective resistance of the infinite network. Infinite network. So write down the question. Find RAB or effective resistance between A and B. Find effective resistance between A and B. So here it is given as this is A, this is B, and here this is connected to resistors in this fashion. They are going up to infinity, and here there is no resistor, there is a conducting wire, and in between this resistor an identical all are identical resistors. Right? Identical resistor is connected in this way, and here also in the same fashion, here also in the same fashion, and it is also going up to infinity. So you are asked to find what is the effective resistance between A and B, provided all are identical resistors. In some cases, they may give these are 2 R's, these are R's, like the different way also. Okay, you have to follow the same procedure. So in this case, even some cases here also some resistance will be given. So what you have to do as a first step while dealing with these kinds of questions is that you have to identify what is the basic element which is repeating, a repetitive element. If you observe from here, you have to imagine that there is an imaginary battery. If current comes here, it divides here, and after dividing here, it again comes here and divides. Like this, it is going on continuing this division process. So if you observe here, this R and R is one element. These kind of elements are repeating continuously and going up to infinity. So this is a repetitive element. This is a basic element. These are all repetitive elements. So the next step, after identifying this, you have to replace all these with one single resistor. Single resistor. This is A, this is B. You have to consider this is R, and this resistor as it is you have to consider R, and the entire part you have to, part of the network, infinite network, you have to replace with a single resistor. And what about this resistance, you may ask. So here what you have to consider is, you have to use one simple logic, that is, this network is going up to infinity. So the entire total resistance of the infinite network may have some value. So let us say that the total resistance is X. To that infinite, it is something like if you have a small bucket of water, you have to follow this logic. If you add this to ocean, the level of ocean will not change. Is it clear? Same way, this is going up to infinity. So to this infinite network, if you add this network, its total resistance will not change. That means, let us consider the total resistance of the infinite network is X. To that we are adding one small element, repetitive element, this element. So the total effective resistance of this, now the entire network between A and B also will be same as this. Is it clear? So this effective resistance also will be X only. So what is that X in terms of R we want? What is that X in terms of R? To find that, here again let us consider here, let us imagine there is an imaginary battery and it is connected to this. So a current is flowing here and this is dividing between these two. As these two are in parallel, try to find the effective resistance of these two parallel resistors. Following? So R and X are in parallel. What is effective resistance? If it is R1, R2, effective resistance will be R1, R2 by R1 plus R2. So it is R into X by R plus X. So you have to replace this with the effective resistance and then again redraw it. This is R, this effective resistance of these two, this is A, this is B, this will be R into X by R plus X. Got it? That is the effective resistance of these two. So now you can observe that now there is a battery, this whatever current passes through this, same current passes through this. So these two are in series. So effective resistance between A and B, effective resistance between A and B, that is RAB is equal to, this is R, this is R, right? So R plus Rx by R plus X, Rx by R plus X, Rx by R plus X. Okay? So now you know that this effective resistance between A and B is same as the resistance of this kind of ocean. Same value, it will be the same. So if you take this X, this is X, and you can take RAB is X only. X is equal to R plus Rx by R plus X. Now on simplifying this further, you can write if you cross multiply, you get R into R, R square plus Rx plus Rx by R plus X is equal to X. Is equal to X. So what is the effective value of this? What is the effective value of this? So again, if you cross multiply X into R into X becomes Rx plus X into X is X square is equal to R square plus Rx 2Rx. So we got an equation here. We have to write this as in the form of quadratic equation. When X is the variable, so we have to write this as X square. Rx, we bring this here, it becomes minus 2Rx. So it becomes minus Rx minus R square is equal to 0. It is in the form of X square plus Bx plus C is equal to 0. This is what is this equation is called? Quadratic equation. So here the variable is X. These constants are A, B, C. Here also a variable is X only. The constants here there is no constant. Here this constant is minus R. This in place of C we have minus R square. That's it. So you have to take those A, B, C values. This is quadratic equation. The roots of quadratic equation will give you X value here. So what is the formula for roots of quadratic equation? X is equal to minus B plus or minus square root of B square minus 4AC by 2A. This formula you have to remember. Roots of quadratic equation. So in place of X we have here 1. In place of B we have minus R. In place of C we have minus R square. So here X is equal to minus B is minus or minus R is plus R plus or minus square root of B square means minus R square is R square minus 4 into A is 1 into C is minus R square minus plus. So minus plus 4R square divided by 2A. A is 1. 2 into 1 is 2. Got it? So this if you take 1's plus 1's minus, you get 2 values. So resistance will be always positive. So you have to take positive value out of those 2 values. So and hence we get X is equal to R plus root of 5R square. R square you take it out. So you will get what is this? R into root 5 by 2. So you can also write this as R into R, you can say 1 plus root 5 by 2 R is one value. This is one value. Is it clear everyone? Whereas if you take minus, you get another value. Because that any value, so if it is root 5, root 4 is 2, right? So it is more than 2. So overall value will be negative. So you cannot consider negative value. So only the positive value you have to consider. So this is the effective value. This is the effective value. So what is X then? R plus root 5R by 2R 1 plus root 5 by 2 into R. Root 5. Root 5. This is the value of X. That is nothing but effective resistance between A and B. This is nothing but effective resistance between A and B. This is nothing but effective resistance between A and B. Is it clear everyone? So this is how we have to deal with infinite ladder networks. Okay? Finished? So okay, next let's see briefly the next concept. Note down fast for me. Right, finished. Is that write down subheading electrical energy and power. Electrical energy and power. Electrical energy and power. Okay. So we'll see first briefly about energy, electrical energy. Energy. Electrical energy, or you can say energy in electrical circuits, or usually electrical energy is nothing but potential energy of electrical equipments. So to understand this, you have to recollect back a small concept called potential energy, electrical potential energy. So if you remember, what is the definition of potential? Potential is work done per unit charge. Yes, work done in bringing unit charge from infinity to a given point is potential. Whereas potential energy is work done in bringing a given charge from infinity to a given point. But potential energy can be taken as W, U or W. So from this you can say W in the external field is nothing but V into V, or Q into V. So the potential energy of single charge in absence of external field is zero. So that is when you are bringing a given charge from infinity to a point, in the absence of external field, there is no opposing force, so hence no need to do any work. So what will be zero? Whereas the presence of external field, whose potential is V, that external field if you are bringing, then potential energy is given as what is work done, V into Q. So here, you have to take this as that energy is can be expressed as E or U, any symbol you can use, or W is equal to V into Q. That is, this is the work done in transporting charge Q in the circuit once. Okay? So, or if the charges are flowing in a circuit, these charges will constitute current. So, you can also say Q equal to what? Q equal to, in terms of current, I into T. Because definition of current is I is equal to what? Q by T, or dQ by dt, or Q is equal to I into T. Because Q is equal to I into T, you can write this as V I into T is electrical energy. Is it clear, everyone? So, briefly you can say electrical energy E is equal to V I T. Let us say this is equation 1. By making use of these relations, you can get these equations. So, whereas from Ohm's law, we know that V is equal to I R. Substitute this V as I into R here, then we will get electrical energy in terms of resistance and current as I square IR into I square R into T. Let us take this as equation 2. Whereas same from Ohm's law only, because V is equal to IR, we also write I is equal to V by R. In equation 1, instead of substituting for V, substitute for I, V by R, then we get V is equal to V into V square by R into T. This is equation 2. So, these different equations you can use to calculate electrical energy in a circuit depending on the given data in the question. Depending on the given data in the question, any of this we have to use. Okay? Next, what is electrical power in a circuit? Before getting into that, you have to keep in mind here is, in electrical circuit, the energy consumed is measured by using a unit called kilowatt hour. So we call it as, usually if you see your household electrical bills, it may be given mentioned as your household has consumed 100 units of electricity, 200 units of electricity, right? What is that 1 unit or 100 unit? That unit is the unit of force is Newton. Like that unit of electrical energy consumed is nothing but kilowatt hour. We call it as a practical unit of electrical energy. It is also energy. What is the unit of energy? Joule. But for measuring electrical energy, we will not use joule. We use kilowatt hour. But while doing numericals, if you come across kilowatt hour, you have to convert into joule and you have to work it out. Because always necessary quantity should be in SI units. Kilowatt hour is not SI units. Okay? So practical unit of, write down, practical unit of electrical energy. Electrical energy is, practical unit of electrical energy is kilowatt hour. Kilowatt hour. So it is expressed denoted as 1 kWh. 1 kilowatt hour is equal to, so 1 kilowatt into hour. 1 hour equal to how many seconds? 1 hour equal to 24. Sorry, 60 minutes. 1 minute equal to 60 seconds. So 3600 seconds. If you multiply this, if you simplify, you can write it as 3.6 into 10 to the power 6 watt joules. Watt second is joule. Watt second is joule. So you can write it as kilo, 10 power 3. So 10 power 2 is there. So overall you get 3.6 into 10 power 6 or 36 into 10 power 5 also can write. Don't confuse. If you multiply with one decimal here, you write it as 36 into 10 to the power 5 joule also. Direct values also sometimes will be asked. Must be clear about this. Whereas this is called practical unit of electrical energy. Here, while dealing with this electrical energy and power in a circuit, we have to remember that whenever you passes some current through a circuit, heat will be generated, heat energy will be generated. So energy exists in different forms. Light is a form of energy, sound is a form of energy, heat is a form of energy. So electrical energy can consider, you can treat and can measure in terms of heat also. Are you following? Heat energy. So while these relations actually are brought into these mathematical forms by a scientist called Joule. Based on his study, we call it as, and he has named this as Joule's law of heating. Joule's law of heating. And he said that whenever we have a resistor in a circuit, whenever you have a resistor in a circuit, and if a current I passes through it, heat will be generated. That heat will be taken as considered as energy. So the heat produced in a circuit, or you can also say it will consume some power and hence heat energy will be produced. The heat energy produced is given by in terms of VIT. So during a given interval of time, say for 1 hour current I is flowing through a resistor R. So in 1 hour or 10 seconds during a time interval, the heat energy produced is given by VIT. In terms of resistance and current, resistance and power, what do you call it? Potential, heat energy produced are given by these relations. The same relations will give you heat energy calculations also. Is it clear everyone? That is briefly about Joule's law of heating, or what do you call heating effects of current. Heating effects of current. Is it clear? Okay, fine. But when some heat is producing, energy is consuming by drawn by the battery, and it is what do you call burning here. So to burn this, we have to do some work to bring it here. That means the rate of doing work in bringing that energy to burn is called as power. We call it as electrical power. Now we copy this. Next note down electrical power. Electrical power. Electrical power. Electrical power P. power is in general, power is nothing but rate of doing work or rate of doing energy. So simply you can say power, electrical power is nothing but electrical energy per unit time, or heat energy consumed per unit time, heat produced per unit time. So this can be expressed as energy. We have expressed in three different ways. Power can also be expressed in three different ways. That is V I T by T. So Dt gets cancelled. We have this one. Another one is I square R T by T. So you get I square R, and V square by R into T by T. Dt cancelled. We get this. These are different expressions for power consumed in electrical circuit. Or power consumed in an electrical circuit. Okay? Power consumed in an electrical circuit. Based on this, what kinds of questions will come in exam? So, number of times different questions based on this have come in different exams, even in medical exam also. So, what kinds of questions will come and how to attempt those? So, let us see few simple questions here. Especially, for example, let's see one simple example. If you have given a cell and having some 20 volts supply, and from this the current I is drawing some current, and it is connected to a resistor R of resistance. You can consider some 5 ohm, and this is further connected to another cell which is connected in this fashion, whose EMF is, I can say 10 volts. 10 volt. Are you following everyone? Yes? Then the question is, so after you should have an idea of what is this EMF and all. But this in general, the circuit we consider like this. The current I is drawing from this, and this current is passing to this, and here, and this current is entering into this. Are you following? That means it is delivering some energy, or we are drawing energy, electrical energy from this. It is passing through this, and when this energy is passing through as a current through the resistor, this will consume, or this consumes energy and generates some heat, and a part of this will be given to this also. This also will consume, and the power, it consumes energy. So you can also say the power is consumed by this. Power is consumed over a given interval of time, and energy is consuming by this battery. But this is giving the energy. So here the question is, what is the power generating by, let us say this is cell A, this is cell B, this is resistor. What is the power generating by the cell A, and what is the power consuming by the resistor? What is the power consuming by the cell? S. What is power generated by A? What is power consuming by B? And what is power consuming by the resistor? The EMFs are given for cells. Therefore, this resistance is given. How to find this? By using this concept. Power is equal to V into I. So, power generated by the cell is, if you know its EMF, you know EMF. As there is no internal resistance. If you know the current passing through it, then you can express V into I gives the power generated by the cell. But what is the I? I is given? No. How can you find I? You have to remember that hereafter, current through any circuit which is having a cell and resistors is nothing but, what is this? Net EMF by total resistance. Net EMF by total resistance. If they are having internal resistances, you should have add those resistances also. But there is no internal resistance, directly can take this. What is net EMF in the circuit? We are talking about the total current. So here if you observe, this is giving the current. So this current is entering here, or you can say the current due to this current into this, they are in opposite directions. So that EMF will be, they are not, if they are in same direction, you can say they are in supporting manner, EMFs will be added. They are in this kind of, what you call directions, you can say they are in opposing manner, and take the difference of the EMFs. So here difference in EMFs is what? 20 minus 10, how much? 20 minus 10, how much? 10. That is your net EMF. What is total resistance? 5 ohms. So what is the current then? I is equal to 2 ampere. That's it. So this current is flowing through this. This current is flowing through. So because of this current, you can see the power generated by this is what? E into I or V into I, VI is VI. What is that? 20 into 2. How much? 20 into 2. 40 watts. Is it clear? 40 watts of power it is generating. So how much power is consuming by this? The current through this into which EMF? What is that? VI. V is 10. I is 2. How much? 20 watts. Out of 40 watt, 20 watt it is consuming. So what is the current passing through this resistor? Power consuming by this. Or heat energy generated. Is that what power consuming? It is nothing but. What is that? In case of resistor, power consuming, if you know its potential, okay, you can take that current into voltage, but you don't know. You know the current and resistance. In terms of current and resistance, what is the power? I square R. So you can take this as I square R. What is I? 2. 2 square is 4. Into R is 5. How much is this? 20. So it is generating 40 watt of power. Out of this, 20 watt it is consuming. Remaining 20 watt it is consuming. So it is balanced. Is it clear? Everyone? So this kind of questions will come based on this. Next. Let us say, if you have a bulb, this is connected to a cell. A line voltage you can call it as. This is the line supply, main supply. And the rating parameters of bulb are given. What are these rating parameters is? So if you are buying a bulb, if you go to shop and if you are buying bulb, there will be mentioned something like wattage. What is the wattage of the bulb? It is 10 watt bulb or 60 watt bulb or 100 watt bulb. Right? Along with that, you usually will see wattage. But along with that, will be mentioned its voltage rating also. Under that particular voltage, what you call power supply or voltage ratings only can operate that. So beyond that voltage you cannot operate. That is called as voltage rating. Power rating, voltage rating will be given. Along with that, sometimes current rating also will be given. If not, you can calculate current rating and also resistance rating of that bulb. So if the power rating of this bulb is 100 watts and it is given that its voltage rating is 220 volts and it is connected to a line voltage or main voltage of potential 220 volts only. The bulb is connected in a household. Usually in India, the line voltage in a household, line voltage will be 220 volts. In Western countries it will be 110 volts, right? If it is connected to this, here you may ask different questions. Number one, what is the resistance of the bulb? Resistance. Or you can also say the resistance rating of the bulb. And second one, what is the power consumed by the bulb? Power consumed by the bulb. What is resistance rating or resistance of the bulb? Resistance of the bulb. Resistance of the bulb means resistance rating. Rated resistance, the rating resistance of the bulb. And what is power consumed by the bulb? How to find this? How to find resistance? Same by using the previous three formulae. What are those three formulae for power? VI, I square R, V square by R. You have to remember those points. Okay? And by looking at those points, how to calculate resistance by knowing power and voltage. Power rating is given, voltage rating is given. By using this, how to find resistance is nothing but resistance rating. We know power in terms of voltage and resistance is P is equal to V square by R. Power rating is this, voltage rating is this. So we can also write it as rated power is equal to rated voltage square by rated resistance. Is it clear? So for here, rated power is given, rated voltage is given. You are asked to find resistance. Simply resistance of the bulb means rated resistance. Okay? So rated resistance is. So find out now. Let's do it. What is the resistance of the bulb? This implies rated resistance is equal to VR square by PR. Is equal to how much? PR square. What is rated voltage? 220 into 220 by rated power 100 watts. So what is rated resistance? Or simply resistance of the bulb is how much? What is the resistance of the bulb? 0, 0, 0, 0 cancel. So what is this? 4, 84 ohm is the rated resistance of the bulb. Got it? Right, very good. So how to find this first part, second part? How to find the power consumed by the bulb? What is this power and what is the power consumed? What is the difference between them? This is rated power. So means this much power only it can consume. Okay? If more than this power it is consuming, it will burn. It will fuse. What is the meaning of it? So, to calculate the what is the consuming power, you have to say what you know here, rated power and rated voltage, and here is one more voltage is there. This is what is this voltage and what is this voltage? This is the rated voltage. This is line voltage or mains voltage. Supply voltage. Supply voltage. Rated voltage is 220. Supply voltage can be maximum this much. Cannot be more than that. It can be 110 volt also can accept. But if you have supplied 300 volts, you cannot accept. That is the meaning of rated voltage. It is designed or manufactured to operate under maximum this voltage range only. Voltage range, maximum voltage range is called what is called voltage rating. Right. So to find the power consumed, let us say PC is equal to how much potential voltage you are applying, and so you know P is equal to V square by R. So V here is nothing but line voltage which we are giving square by resistance. But you know line resistance will be fixed. In both cases we use same resistance one. So this will give you power consuming by the bulb. Is it clear? So how much power it consumes? VL square by R. What is VL? 220 into 220 by what is resistance? So you can take this as 484 or 22 into 22. This one you can take 484. So 22 tens. 22 tens. What is the power consumed? Power consumed is how much? This much. If you are supplying this much line voltage, entire thing will be consumed. If its voltage rating is if its voltage rating is different or line voltage is different, then consuming power will be different. If any of these changes, then will changes. Because if this changes, resistance changes, and hence consuming voltage also changes. So like this we can calibrate. Are you ready? We know power. Which power? This power. That's what I am telling. What is this power is called? Rated power. This is consuming power. In this case, it's the rated voltage and the line voltage are the same. So consuming power and rated power also you have got same values. If any of these are different, is it different? You can check with the numericals, different numericals. Practice some other thing, then you will understand. Next, write down. Next, write down. Out of the two bulbs shown in figure, which one glows brighter? Out of the two bulbs shown in figure, which one glows brighter? We have two bulbs connected in series. In series, it is having 40 watt rating power and 110 or you can say 220 volt rated voltage, and this is having 60 watt rated power and same 220 volt rated voltage. This is connected to a line supply of V is equal to 110 volt. So which bulb glows brighter is the question. Write down here as a note. This is the question. Note. Write down a note. The bulb which consumes more power will glow brighter. The bulb which consumes more power will glow brighter. Okay, so which consumes more power? So after this is the question. So we have to follow few points here. That is, first, to find the power consuming by each bulb. First you have to find the resistance, the rating of the bulb. Simply resistance of the bulb is nothing but resistance rating. Step 1. Find the resistance of each bulb. So resistance of first bulb is R1 is equal to, it is nothing but rated resistance of first bulb. Simply you can take it as R1. It is nothing but rated resistance. To find the rated resistance, you have to use rated parameters only. That means rated power and rated voltage. So it is equal to, what is that actually? P is equal to V square by R is equal to V square by P. This is rated voltage of the first one by rated power of the first one is equal to, what is rated voltage of this? 220 into 220 by power is how much? 40. So what is the answer? What is the R1? R1 1210. 0 cancel. 2 2s, 2 11s and 2 11s. So it is 1 2 11 2s, 11 square is 121, 10 is there, 1210 ohms. You can say R1 or R1 is 1210 ohm. Got it? Next, R2 is equal to VR2 square by PR2. PR2 square is also same. 220 into 220 by PR2 is 60. 0 cancel. 2 3s, 2 11s. So what is this? How much? So it is, do it now. 800 806.6 806.6 ohm R2. That is first step. We have to find the resistances. Then power consuming, step 2 should be the consuming power consumed. The bulb which consumes what is that? The bulb which consumes more power will glow brighter. Okay. So how to find the power consuming? Power consuming is equal to line voltage square by resistance. Line voltage square by resistance. Got it? Fine. But the total, this is in series. This is in series. So this current I is passing here. The current I is passing here. So you can say the same current is passing here. So you can write in terms of line voltage square by R. And also write it as, what is this? Current I square R. Line current or the current due to current given by the line voltage. Line voltage. So either way you can take it. So here, as they are in series, the constant parameter for both bulbs is nothing but current. So calculate the current and substitute, then you can get consuming power of each bulb. So because resistances are different, so first try to find out what is the current. What is the current? Current is equal to net EMF in the circuit by total resistance. So where you can write I is equal to net EMF by R total. Net EMF is how much? 110 by R total. R1 plus R2, they are in series. So R1 plus R2. What is that? R1 plus R2. 1210 plus 800. 806.6. It is nothing but R1 plus R2 in series. Substitute and find out what is I. Or you can keep this as these and then you can simplify it later. So here, so you can write this here as this is equal to 110 into 110 divided by R1 plus R2 values. You can find out R1 plus R2. So 1210 806.6 661 2016.6 2016.6 into 2016.6 into R. What is this? In general. Okay, wait here. I square, we are taking it as I square R. I square R. So this is general relation. Now, when we are trying to find the power consuming by the first bulb, we have to take this as R1. So R1 you have to take. If you are finding the power consuming by the second cell or second bulb, so this is I square into R2 you have to take. I will be same, common for both. I will be common for both. Right? So substitute those values and find out PC1 and PC2. Power consuming by the first one, power consuming by the second one. V square by R form. So you can do that way also. Either way you can do. Whichever it takes less time consuming, that you can follow. We take VL square, but here, so this is not VL, you shouldn't take this one, because here current will be same. VL for the first one is VL1 and line voltage for this is VL2. Potential will divide. Again it involves some calculation. So what is V? You can say it is a potential divider according to potential divider rule. You know R1, R2s. So V1 is equal to as from Ohm's law, V is equal to IR. So total I into R1 by R1 plus R2. Similarly, I is nothing but net EMF by total resistance. And supply, you have to find I, then you have to calculate VL1 and VL2. So that way you can do. Otherwise, this will also be done. Both will have same calculations. So find out this. This here we are trying, this is general, but now we are trying to find here PC1. This for first one. PC1 is this into R1, 1210. 1210. Finished? These kind of questions are important in need point of view. Different years, similar kind of questions are asked repeatedly. So one way or the other. So go through this properly and practice. So this may have a little lengthy calculation sometimes, but so the values of these powers will be given in such a way that you may need less time. So it may not consume more time. This kind of questions will be given. Okay. So the calculations also will be what we call not decimal oriented calculations will not be given to save the time. But sometimes simple calculations they may give. So you have to do that. The timing based on every question's average difficulty. The difficulty of these questions will be framed. So accordingly, the time consuming also depends. So calculate and find out. Then the power consuming by which bulb is greater, that the bulb will glow. Which bulb is greater, that bulb will glow brighter. That is what we have to compute. Okay? And this is how you have to work out this kind of questions. This is briefly about what we call electric energy, power and heating effects of current based questions, a few questions. And sometimes you may also come across some questions related to the energy consumed by the devices. This is power consuming. Energy consuming also. Energy consuming basic questions also you may come across. So let me give you one question based on that. Yes, what is the time? 9:30. 1. Right? See here, the question is given as in a house there are 4 bulbs, each of 50 watts. In a house there are 4 bulbs. So number of bulbs is equal to 4. 4 bulbs, each of the power of bulbs, each bulb is how much? 50 watts. And 5 fans. Number of fans is equal to 5 and power of each fan is equal to 60 watts. They are used at the rate of 6 hours a day. The electrical energy consumed in a month of 30 days is. So they are used for 6 hours. T is equal to time consuming is 6 or 5 hours. 6 hours a day and 30 days. 30 days. Then what is the electrical energy consumed? What is the total electrical energy consumed in 1 month? How many units of energy it will consume? This kind of questions also important. what is the total electrical energy consumed. You have to, you know that energy consumed is nothing but power is energy by time. Power is energy by time. From this you can write energy is equal to power into time. Is it clear, everyone? If you have one device whose power is this, and if it is consuming this power for this much time, energy consumed is the power into time. If two devices are there, into 2. Got it? So, but here the total energy consumed is equal to number of devices into the power of each device. So you can say that here number of bulbs into the power rating of each bulb into the time consumed, how much time this power is consuming energy. So we can take this as T. All are consuming this energy for the same time duration, right? So plus number of fans into power of each fan into the time taken by these fans to consume this power. Is it clear? So this gives you the total energy in terms of kilowatt hour. If you want, you have to divide this by 1000. Got it? So can you find out what is this? Sorry? 1 month. We are asking for 1 month, right? So 3 hours. 6 hours. 6 hours each day. 6 hours and 30 days. Okay? So what is power consuming by energy consuming by this? What is energy consuming by that? And hence what is the total energy consuming? Right? So find out number of bulb. What is the number of? What are those? Number of buttons or number of bulbs? So what is the total energy consumed? So the options, correct option is how much we have got? 90.8 kilowatt hour. 90.8 kilowatt hour. Okay. So overall you get total 90.8 kilowatt hour if you simplify this. Right. So try to work out few more questions based on these methods, based on electrical heating effects. Joule's law of heating. This is another very small concept but important. As time up, can we spend some 10 minutes and see briefly about combination of cells. Combination of cells. Write down next our heading, combination of cells. To understand this, you should know what is a cell first. Combination of cells. What is a cell? What is EMF of a cell? And what is internal resistance of a cell? And some special points related to cells. Actually, EMF of a cell. EMF of a cell. In general, the circuit symbol of cell is this. We have a higher potential and lower potential terminals. two terminals. Okay? So if its EMF is given as E, that means it is the potential difference between higher potential terminal and lower potential terminal. This is terminal A, this is terminal B, and if it is not having any internal resistance. Ideal cell will have zero internal resistance. If the internal resistance is zero, then we can say VA minus VB. And if it is not connected to any other resistor also, in open circuit, in open circuit, potential difference between terminals of a cell is called EMF of a cell. We can define this in different ways. So in this case, you can say VA minus VB is equal to E. In open circuit, the terminal potential difference between the terminals of a cell in open circuit is called EMF. So that is mathematically given by VA minus VB equal to E. It can be defined as if it is connected in a circuit, the work done in moving a charge through the circuit once will also be called as EMF of a cell. Work done. Okay? So here EMF full form is electromotive force. But the word force is nothing to do with the term. It is not force. It is nothing but potential difference. It is similar to work done. It is not force. Okay? Right. So here, to understand the combination of cells, we need to have an idea of few more basic terms or terminology related to these cells. That is, during charging, during discharging, how to find the potential difference of a cell. This is EMF of a cell. It is an ideal cell. In general, if you have a non-ideal cell, non-ideal means practical cell. Usually a practical cell or non-ideal cell will have EMF and some internal resistance. Are you following? If this is connected to an external resistor of resistance R, then you may ask to find first what is current in the circuit, and second what is the potential difference between terminals A and B of the circuit, A and B of the cell. Yes. Here current is nothing but this can also be, because it is an internal resistance or they are separately mentioned as a resistor. So when a current I is drawn from the cell, automatically this passes through this passes through its internal resistance also. And that current from Ohm's law is given by I is equal to V by R. But here we express this as net EMF by total resistance. Your net EMF is E, total resistance is R plus R. Is it clear now? That's it. Whereas what is potential difference across this? Here, for this case we discuss here potential difference across this. That means here internal resistance will come here only, within the terminals only. So as current is flowing through the internal resistance in this direction, you have to follow some sign conventions. According to the sign conventions, you have to understand this. The other way, you have to say Kirchhoff's laws. The idea of Kirchhoff's laws to some extent you should know. We'll discuss about that again. So here, when it is passing here, you have to say this is higher potential, lower potential. Potential difference across the resistor is I into small r. So this is for plus E is equal to potential difference between these two. So you can also say VAB is equal to E minus I into directly again. VAB is equal to E minus IR. Is it clear? Yes, everyone? Here I will give two more sub cases. One is charging condition, another one is discharging condition. For a cell, during charging, what is potential difference? During discharge, what is potential difference? During discharge or discharging. What is potential difference? Potential difference. PD. Potential difference. First case, second case. For a cell, you have a cell of EMF E, internal resistance R. During charging means current should be given to that. I is entering into the cell. Discharge means this is cell having internal EMF E, internal resistance R. Current is drawing from the cell. In that case, it is said to be under discharging condition. In this case, it is said to be under charging condition. Is it clear, everyone? Now, during charging condition, during charging condition, you have to understand that. You have to remember always that one more point here as a note. As a note. Current always flows from higher potential to lower potential. Current always flows from higher potential to lower potential. Current always flows from higher potential to lower potential. Now, current is flowing in this direction means this will be higher, this will be lower. Are you following, everyone? So based on the sign convention, if this is A, this is B, mark, if you mark, then you will get, in case of charging, VAB is nothing but VA minus VB is equal to E plus IR. During charging, potential difference across the terminals of a cell is E plus IR. Or we can also conclude that potential difference across the terminals is greater than EMF. EMF is E plus something, so greater than EMF. Whereas in case of discharging, VAB, we take this is A, this is B, VAB is equal to VA minus VB is equal to E minus IR. If current I is entering here, current I is going here. E minus IR. So E will have some value, minus something will be less than E. So you can say potential, terminal potential will be less than E, then greater than E. Based on this theory points, conceptual points also sometimes we will get questions. These two relations are very important. Based on this, direct questions also will get questions. Okay? Right. Now, write down the heading combination of cells. Combination of cells. Okay. Fine, then let me stop. Combination of cells part will continue in the next session. Combination of cells and Kirchhoff's laws, etc. So in the next one session we have to finish this chapter. Okay? Kirchhoff's laws, Wheatstone bridge, meter bridge, potentiometer, everything. One session we have to finish. So be ready and we will finish and we will try to work out some questions also in next session. Okay? Fine. Right.